Hello everyone. Um, Today we are going to continue our chapter number 5. Um, so in the last class we have started the chapter 5 with a method called present worth method, and we said that is used to evaluate a single project to see if you want to accept that project or not. And the method is that you want to convert all the different cash flows on the same timeline back to the present time and sum all of them up and to see if that total present worth is bigger than zero or equal to zero or not. So if it's bigger or equal to zero, then that project is profitable. Okay, so you want to accept that. Otherwise, you want to reject it. And one thing to be noticed is that while you're doing the um, interest calculation, the conversion of the cash flows, the interest rate you want to use is called MARR, minimum attractive rate of return. So that is something always given in the problem statement. And actually, there are many ways in the real world to determine the MARR for a company or even for yourself. Okay, and also we have learned the concept of bond, and we said there is an equation we can use directly to calculate the bond price that you can afford. That's the maximum price you want to pay for a specific value of bond. And we have seen many examples for this present worth method. Okay, and today we're going to learn the other methods. They do the same work. They also evaluate the single project to see if you want to accept it or not. So another special case about the present worth method is called capitalized worth method. Okay, this is not a new method. It is just an extension of the present worth method, just like the bond issue. Okay, it's a special case. So what is the capitalized worth method? You can imagine in some cases, um, the realization of your revenue or the benefit from a project could be very, very long. Cases could be building a road, building a bridge, building a tunnel. Okay, so those civil structures, they're gonna stay there for a long time. You're not gonna build a bridge temporarily and then you take it off. Usually you won't do that. Okay, and you of course you don't like build a road and then build a highway and then after 1 year you take it off. That's very uncommon. So usually the civil infrastructures, they are gonna stay there for generations and generations. So sometimes you can even say that the benefits from them are coming year by year until that infrastructure is retired. And of course, every 10 or 20 years, the Department of Transportation is going to maintain those key infrastructures so that their lifespan can be seen as infinite. Because we want the service for us, for our next generation, and for generations to come. Okay, so that is why we want to use the capitalized worth method, because the timeline for that project is going to be infinite. So now let's take a look at this definition. In some instances, revenues and expenses are not realized over a finite number of periods, but over an infinitely long period. You can see it as an number of interest periods goes to be an infinite number. The capitalized worth method can be applied in these cases and is a special case of the present worth method. Why it is a present worth method? Because if we are looking at a infinite timeline like this, okay? It's infinite, so I don't know where is the end of the timeline. And at the beginning, you might invest some amount to build a bridge, right? And then every year you have that bridge serving the traffic, serving that community, okay? And those services will, generate economic impact, which can be calculated as some receiving, okay, in the society. So every year you're gonna have some revenues, and also of course you have costs to maintain that bridge, but the net benefit is gonna be some cash flow income. Okay, so the arrows, they are annuities. Okay, and they are telling you that every year your bridge is benefiting the community in some specific amount of dollars. Okay, and it happens every year. Until generations after generations. So we can say this type of problem is a infinite time project problem, and still we wanna evaluate if this type of bridge is a better choice compared to the other type of civil infrastructure investment. Okay, you still want to see if you want to accept it or not. So the way you do that is still you want to convert everything back to the present time. Okay, so for this amount investment, it's already at present, so we don't have to convert anything about that. But another part, like this annuity, you want to convert that back to the present time. But if you go to check the interest tables in the Appendix C in your textbook, you will see that the very last row of that table is going to be n equals to 100. Okay, so what do you do if the n is going to be infinite? What factor do you use? Well, you don't really have that factor. So we need to use this method called capitalized worth method. It is very easy to use. It's first thing is that you need to know it's used to convert the annuities on the infinite timeline back to the present. Okay, so it's only for converting the annuities. Okay, so because of course if you are converting the annuities, then you're gonna use this equation, right? So a times p slash a I percent, usually the infinite symbol will be n, right? That means your timeline is finite. But if it is an infinite time, then we have some mathematical equations going on, and you don't have to worry about the internal calculation, but somehow it is proved that this equals to this very simple equation. So it means if you can determine that the timeline is going to be infinite and you want to convert all the cash flows, the annuities along that infinite timeline back to the present, you can just use the A, that annuity, over the interest rate. Okay, so that is the capitalized worth method. Okay, that is very easy equation to use, but you just need to know when are you going to use it. Okay, and because this is to help converting the annuities back to the present, So actually, this is just one type of PW method. All right, now let's take a look at the real case. Okay, so for example, a project which pays you 1,000 per year. So 1,000 per year, that's you're receiving every year the same amount. So it is annuity at an interest rate of 4%. Okay, so now let's take a look. If we say the timeline is 10 years or 20 years and 50 years and even longer, 100 years, and then if we say it's 1,000 years compared to 10 years, we could say that's something infinite. Okay, so let's take a look at the values of these annuities. When we convert them back to the present time, what happened? What kind of values of the PW we can have? Okay, and how do we use that simplified capitalized worth method to calculate the very last item? Okay, so if we say, so first of all, let's just draw the diagram, okay? So if it's 10 years, the diagram is gonna be 0, 1, 2, 3, and then 10, right? And then we know that every year you're gonna receive 1,000 for that project. So it is the annuity at the end of every year, and A is 1,000. And we know the I is 4%. Okay, so right now our task is to convert these annuities back to the present time, and then sum that with some investment at the present time, and then that's gonna be your total PW. But at this point, we only focus on the PW from the A, okay? Because you don't have to convert anything that already happened at present. Okay, so now how do you calculate the PW from, excuse me, the PW from A? How do you calculate that? It is to find P given A. So the equation is going to be A times P slash A, 4%, number of N, now it's 10, right? And if you calculate this, you're going to get the value of 81110.9. Okay, so that is the present worth of these annuities occurring at the end of every year for 10 years. Now let's do the second case. Say if it's 20 years, okay? So first we still draw this timeline. And 0, 1, 2, 3. But we end it at 20. Okay, so again, every year you still have that 1,000 as you are receiving, net receiving, okay? I is still 4%. So for this case, the PW from these annuities is gonna be still A times P slash A, 4%. But now the number of years is gonna be 20. And then the final result is 13,590.3. Okay, now let's do the third case. So we have more years, 50 years. But still you can use the interest table in Appendix C. Okay, so almost the same, just with a longer time period. A is 1,000, I is 4%. So now the PW from these annuities is gonna be A times P slash A, 4% and 50. And now it is 21,482.2. Okay, now let's say if we have 100 years. Okay, so we end up at 100. Wait a minute, it's 99. Okay, so every year you still have these annuities. Okay, and your I is 4%. So the PW from these annuities for 100 years is gonna be A times P slash A, 4% and 50. And 100. Luckily, in the interest table, you have your last row giving you the factor value for n equals to 100. Okay, and if you use that value, you're gonna have 24,505.0. Okay, then what is the value for infinite number of years? Okay, for example, like 1,000 years, 2,000 years, what will happen? Okay, so before we answer that, we know that we're going to use the capitalized worth method. Okay, that's going to be PW is going to be from A is what we call the CW, capitalized worth, and it's going to be A over I. Okay, and then the A is 1,000, I is 4%, so that answer is gonna be 25,000. We know we're gonna use this, but now let's just illustrate all of these values on a chart so you can have an idea like why we say if it's infinite years it's going to be just this simple equation without any factor method. So now let's try to draw the values on the chart. Okay, so let's see. We need a space to draw it. Let's just draw it here, maybe here. Okay. So let's say our y-axis is the PW from A, or we can say that's the CW, okay? And the x-axis is gonna be very long, that's gonna be years. Okay, so we start with 10, 20, 50, 100. Maybe we have 200 and we don't know. Okay, so when it goes to the right side, it's infinite. So what we have for the PW for every different number of years. So when number n is 10, we know it's 8,000 something. So let's say here is 10K. And then it's 15K. And then 20K. And then 25K. Okay? See, that's the values on this y-axis. So when time is 10 years, we know it's 8,000 something. So the dot is gonna be here. When it's 20 years, it's 13,000 something. So we know it's lower than 15. When it's 50 years, it's 21,000. So 50 years, it's over 20K. And when it's 100 years, it's 24,000 something. So we know it's getting closer to 25. Now let's just draw the line of 25 on this so that we can see it clearly. So 24,000 something should be very close to that line. Okay? And so if you can calculate when it's 200, I can tell you it's gonna be even more closer to this line of 25K. So if you connect these dots, you're gonna have a curve opening to the bottom and getting closer and closer and closer to this dotted line, which gives you the 25K as your present worth value. But before the number of years get to the real infinite, this curve is going to be just getting closer and closer to this dotted line. Okay, it never gets to the dotted line until it gets to the infinite number of years. So that makes sense. So which means the infinite time your present worth is gonna be 25,000, and that's the maximum. So every number of years, it's just getting closer and closer to that maximum ceiling, but never touches it. Okay, and then so this is just a visualization to tell you that for infinite number of years, we can just use the simplified equation to give you a number for present worth, and that present worth will be the ceiling. So until you get to the infinite years, the values of present worth is going to just get closer and closer to it. All right, so the next section, we're going to talk about another new method to evaluate a single project. It's called the future worth method. Okay, so just recall that the present worth method is going to convert all the cash flows back to the present time and compare that with 0. And so the same logic, the future worth method is to convert all the cash flows to the future time, okay, to the end of the timeline, and then compare that with the 0 as well. That's very easy to understand, okay? And of course, the interest rate you're using to convert the cash flow to the future time is also the MARR. Okay, so also you have different scenarios to convert. You can have single cash flow at the beginning. Okay, so you have single amount investment at the beginning, and after many years, you're gonna have some receiving out of that investment. And what is that feature worth? You just wanna convert that to the future time, okay? And also, if you have multiple transactions or multiple cash flows, you're gonna have multiple parts of the FW, FW1, FW2, FW3, ... So you want to convert multiple times using the factor method we have learned in chapter 4, and then you sum them different parts up at the end, and then you have the total FW and compare that with 0. Okay. Also, you may have annuities going on. Okay. So annuities going on, and the thing is you want to convert the annuities to the end of the timeline and have a FW. And once you have the FW, including all of the cash flows, you're going to compare that with 0 to see if it's bigger or equal to 0. If yes, then that project is acceptable. If no, you're going to reject it. Easy to understand. So this example is exactly the same as the one we used for the present worth method. But I just want to give you a comparison. Like if you use present worth method and if you use future worth method, are you going to have the same conclusion? Okay, so that's very interesting to see. So okay, let's just use this. Okay, and the first thing, okay, so just to remind you what this problem is. So a piece of new equipment has been proposed by engineers to increase the productivity of a certain manual welding operation. So we're going to decide if we want to buy this new equipment or not. Okay, and we know that the investment cost. So at present, you need to pay 25,000 to buy this equipment. Okay, and then after 5 years, you're going to sell it to the market, and you can get 5,000 from that salvage. Okay, so somebody will buy this equipment as a second-hand equipment, and they will pay you 5,000. That's it. So that's one receiving you can get at the end of the 5 year. And also at the end of every year, this new equipment is gonna save you some money. Okay, they're gonna lower your cost and increase your productivity. Anyway, so the net profit for your company is gonna be 8,000 every year. Okay, and it is also given that the MARR for the company is 20%. So now you want to use the FW method to decide if this is a good project to accept or not. Okay, so now let's just draw this diagram. Actually, it's gonna be exactly the same as the one we drew for the present worth method. So timeline 0, 1, 2, 3, 4, 5. Okay. At the beginning, you're gonna invest 25,000. So it's outgoing and it's long. The arrow is going downward. And every year you're going to receive, okay, so at the end of the 5th year, you're going to sell it at 5,000. So that's one of your income at the end. So it's 5,000, a shorter arrow going up. And then every year you're gonna have net profit 8,000. So you're gonna have some annuities going on this timeline. Okay, so at the end of the 5th year, that's additional 8,000, and the A is 8,000, and your I% is gonna be your MARR, which is 20%. Okay, that's the diagram. And now let's look at the problem. It asks you to use the FW method, future worth method. So you're gonna convert everything back to convert everything toward the future. Okay, so the question is, what is the future worth? And actually, the future worth is you convert everything to the end of the 5th year. Okay, you can write it as F5. That's exactly what you want. Okay. So what is that? First, we need to determine how many parts of that future value has. Okay, so we have this 25,000 initial investment at the present time. Okay, so we have FW part 1, which is from the 25,000, and it is the present value, okay? And we want to convert that to the future value. And the second part is the 8,000 annuity. So you have FW part 2, which is from the annuity equals to 8,000, and it is annuity, and we want to convert that to a future value. Third part is from the 5,000, okay, the resale price, and it is a future value. So actually don't have to do any calculation. That already happened at the end. Okay, so now you can go ahead and calculate each one of them. So FW1 is to find the F given P, right? So the equation is gonna be P times F slash P MARR N. And P here is 25,000. Be careful because this is expenditure, so you're gonna have a minus symbol in front of it. The minus or the negative sign only tells you it's an outgoing cash flow, it's expenditure. Okay, it's not some value lower than 0. So negative 25,000 times a factor F slash P 20%, N is 5. So it's negative 25,000. You need to find out the factor in the table of I equals to 20. So it's to find the future given present, it's this column, and the number of N is 5, so this is your factor. $2.4883. The final result of this part is negative 62207.5. Then continue with FW2. FW2 is to convert annuity to a future value. So the equation is A times find F given A MARR number of N. Okay, A in this case is 8,000, and because this is a receiving, so it's a positive symbol. Okay, so positive 8,000 times the factor is F slash A for 20% for 5 years. So it is positive 8,000. We gotta find this factor. It's F slash A, so it's this column. And N is 5, so this is your factor. 7.4416. So the final result of this part is 59532.5. 32.8. The third part is already occurred at the end of the 5th year, so you don't have to convert anything. So it is positive 5,000. Okay, now you need to sum the three parts up to know what is the total FW. So negative 62207.5 plus 59,532.8 plus 5,000. The final answer is $2,325.3. And this one, if you compare that with 0, it is bigger than 0. So we say we want to accept the proposal. Okay, so as what you can see, the answer is the same as using the present worth method. Okay, so after that, we're going to learn another method called annual worth method. So it's the same logic. Present worth method is to convert every cash flow back to the present time, and then you sum them up, and then you compare the total present worth with 0. And future worth method, what we have just learned, is to convert all the cash flows toward the future time, and then sum all of them up as a total future worth and compare that with 0. So the annual worth method is actually to distribute all the cash flows on the diagram and to see if the total annual worth will be bigger or equal or smaller than 0. Okay, that's the same logic. It's just to convert the cash flow to a different time. Okay, so let's just use this same example to show you if using the annual worth method, are we going to have the same answer for this proposal. So we just copy that cash flow diagram here. That is your 25,000 initial payment for the equipment, and then you have 5,000 salvage, and then you have another 8,000 annuities going on, which is 8,000, and your MARR is 20%. Okay, so now we need to convert every cash flow to annuities. So what is the AW? And we know that AW comes from 3 parts. Okay, so first part, you need to convert this 25,000 present value to annuities. And the second part, you have this annuity. It is already annuities, so you don't have to convert it. You just copy it. And the third part, you're going to have this 5,000, which is a future value. You want to discount it to every year. Okay, so AW1 from the 25,000. It is a present value. You want to convert that to annuities. AW2 is from the annuities of 80,000, which is already annuities, so you really don't have to do a calculation at all. And AW3 is from the 5,000 at a future time. So it is a future value. You want to convert that to annuities. Okay? Okay. Okay, now let's just go ahead and calculate AW1. What did I do? AW1, what's that? It's to convert a present value to annuities. So the equation is P times A/P MARR, and P is 25,000. Don't forget about the negative sign. And that factor is A/P 20%, and is 5. Okay, so it's negative 25,000 times a factor. So the factor is from this table, I equals to 20%. It's to find A from P, so this is the column, and number of n is 5. So this is the factor you're gonna use. So 0, 33, 44. The final result is negative, how much? 8,360. So if you convert the present 25,000 to every year, that's gonna be 8,360 every year. Okay, and it's negative. That's your expenditure. And AW2 is already an annuity, so it is positive 8,000. You don't have to convert. Okay, and AW3 is a future value, which is 5,000. You want to convert that to annuities. So the equation is F times A/F MARR and N. The F is 5,000. Again, it is positive. Okay, so A/F from the table of 20%, N is 5. So positive 5,000. The factor is from the column of A/F, and number of n is 5. So that's the factor. So it is 0.1344. The final result is 672. So what is total AW? That's the sum of these three parts. AW1 is a negative number. AW2 is a positive number. AW3 is a positive number. The final result is 312 dollars. So it is positive, bigger than 0. So we say we want to accept the proposal of buying this new equipment. So you can see that although we are using different method here, all of them will give us the same answer, which is to accept this project. So in the real case, if you have a single project, you don't have to use all the three methods. Okay, you just pick up whichever you find you're comfortable with. For me, I always use the present worth method because that will tell me the value of at the present time. Okay, it's easier for me to make decision. Okay, so but you can have your own choice. Okay, you can use either PW or FW or AW method. Okay, so there are other two methods. They're not converting the values to a different timeline, but they are to calculate the interest rate, okay, going on the timeline. and compare that interest rate with your MARR. So if that interest rate is bigger than or equal to your MARR, then you're gonna accept that project. Otherwise, you're going to reject that. Okay, so in what cases you want to use this different type of method? So this method, the first of that two methods, is called internal rate of return. Internal, okay. The next method is gonna call the external. So just give you a heads up. It's shortened as IRR. Okay, internal rate of return. When do you use it? So this method solves for the interest rate that equates the equivalent worth of cash inflows to the equivalent worth of cash outflows. Okay, what does it mean? So the equivalent worth of all the cash inflows, you can consider it as the revenue, right? Because every year you have income. In the end of the timeline, you also may have income. So all of these incomes, if you convert that to the present worth, that's the present worth of all the revenues, right? All the incomes. And also, you might have costs, expenditures going on. You need to pay the initial price, right, to buy the equipment. And every year you need to have a maintenance cost, operation cost, right? And at the end of the timeline, you might have disposal cost. If you don't sell it, you might want to trash it. But to trash it, you need to pay, okay, sometimes, if it's a huge metal equipment. Hard to recycle especially. So if you convert all of these expenses back to the present time, you're gonna have a present worth of all the expenses. Okay, so as a businessman, what do you want to do? We said we always want to at least have our expenses recovered by our revenue. Okay, so that we gain nothing. At least we're not losing money. Okay, we're even. So that's why we want to have them equal to each other. And the I prime percent, which can make this equation happen, that is called the internal rate of return. Okay, so you can imagine you're gonna have some factor method on the left side, some factor method on the right side, and all of them, what you don't know is the I percent. Okay, you know the cash flow, you know what factor you're gonna use, but actually you don't know what I make them equal to each other. So you're gonna solve that equation to find out the I prime percent. In our class, we don't need to do the calculation of that. It's very complicated. But the takeaway is the I prime percent is something can make your expenses recovered by your revenue. Just make it even, okay? So that you don't lose, you don't gain, you just make even case. And that I prime is called internal rate of return. Why it's called internal rate of return? The internal means all the revenues generated by the project will be reinvested at the same I prime percent in the same project. Okay, imagine that you're your iPhone company and you sell iPhones, and all the revenue you get from selling the iPhones will be reinvested into the production or design of a new iPhone, right? So you're gonna re-input the money, all the money you gain into the same business. Implies that the I prime, the interest rate, stays the same. Okay, that's why it's called internal rate of return, because you're still keeping the money in the same project. Okay, and once you solved the equation and you get the I prime percent, you're gonna compare that with your MARR to see if it's bigger or equal or not. So if it's bigger or equal to the MARR, then you wanna say that proposal is acceptable. Otherwise, you're gonna reject it. Okay, so the IRR is actually referred to as the break-even interest rate, right? Because you're making this equation happen, and when it happens, you just make an even case. You don't gain money, you don't lose money. You just keep your cost recovered. Okay, barely recovered. And and here is just the equation I was talking about. So on the left side, this is all the present worth of your revenues. R is revenue. And on the right side, it is the present worth of all your expenses. So you want to make your expenses recovered by the revenue, which means you want to make these two sides equal to each other. Okay? And this is how you calculate the unknown I prime. And there are some warnings to use the internal rate of return. So what it can be used is to compare IRR for one project to MARR to answer the yes or no question. Okay, so if you have a single project, you want to say yes to it or not no to it, you use the IRR method. But what you cannot do is you cannot calculate the IRR for different projects and to compare the IRR. You might imagine, okay, I would compare all of the projects to see whose IRR is the highest, so I'm gonna pick it. No, because you remember the IRR is just break-even interest rate. So means whichever IRR case you take, you still don't gain money. That's not what you want, right? What you want is you gain money, you have positive profit. Okay? But if you just compare IRR for different projects, all of these IRRs are only make break even. Okay? And so although one IRR could be higher than the other IRR, but that project will do the same thing. It only gives you an even case. You don't gain any profit out of any of them. So that's why you don't want to compare IRR to another IRR. Okay, you just want to see one single IRR if it's bigger than or equal than MARR. Okay, because if it is higher than your MARR, which means if you use MARR to convert the cash flows, you're gonna get positive present worth or future worth or annual worth, and that's what you want. Okay, and also IRR, this is also very important. It assumes that the cash inflows is reinvested at the IRR in the same original project. That's the iPhone example I just gave you. The IRR does not work when the revenues are reinvested in another project, which we can say external project, with a different interest rate. So say if you if you sell iPhones and you have some profits, but you didn't reinvest that profit into your iPhone business, you instead you invest that profit into a television business, okay? And that television business is going to have totally different interest rate compared to the cell phone industry. So in that case, you cannot use IRR method. So what do you use? That's the case when you want to use the external rate of return method. Okay, so when do you use ERR, the external rate of return method? When the revenue generated by a project cannot always be reinvested at the IRR, means you need to reinvest it into another project with a different interest rate. In that case, you want to use the ERR. Okay? And then another concept is the epsilon percentage. The epsilon percentage is also an interest rate, but that is the interest rate for the external project. Okay, so that's the external project you reinvest your profit. So the ERR method allows for an external reinvestment interest rate, which is written as epsilon percent, to be considered. Okay, so epsilon percent is the rate that cash flows generated by the project externally. Okay, so this is another very important point is the ERR, external rate of return, is not the epsilon percent. So there are different concepts. Don't get confused. Okay, don't confuse these two things together. And let's just generally talk about the method. You're not going to, use the equation to calculate the ERR, but I still want you to understand this, the method, because it is a very real world problem. So the method is when you want to calculate the ERR, you want to first have all the net cash outflows discounted to time zero. At what interest rate? At the epsilon percent. Because you're reinvest all the money to another project with the epsilon percent as your interest rate. Okay? And the second step is you want to convert all the net cash inflows to a future time with the epsilon percent, which means all the receivings you get from the project, you're going to reinvest that to a future time, to this external project. And the ERR is the interest rate I prime that establishes equivalence between these two quantities. So first, you convert all the outflows, so the spendings, and back to the present time at the epsilon percent, because you imagine that those spendings you could have invested them into another external project. Okay, so you want to convert them back to the present time. And then all the inflows, the receivings, the profits you generate from this project, you imagine that you could invest them into another external project. Okay, but that will happen in the future because the receivings are all the money you get now, and you can only go to the future time in reinvestment. So you convert all of the inflows to the future time. But there is I prime percent, which can make these two quantities, right? The out cash flows and the outflows and the inflows cash. There is some I prime can make them equal to each other, which means you don't lose, you don't gain. It's still a break-even case. Okay, and that I prime is ERR. And at the end, you want to compare that ERR with MARR to see if it's higher or equal to the MARR. If yes, you want to accept that project. If no, then you want to reject it. So this is the long equation we're talking about. And you can see that this part is actually to convert all the expenses or the outflows, cash outflows, back to a present time. Okay? To a present time. And then on the right side, this is to convert all the revenues, the incomes, to a future time. And you see that these conversions are made by using the epsilon percent. That's the interest rate of the external project. So now we're looking at some I prime. Okay, that I prime can make these two quantities equal, but to make them comparable, we said we always want to convert the cash flow to the same time spot, right? So we choose to convert the present value to a future value using this factor. Okay, so first we convert the expenditures back to the present time, and then we use the I prime to convert it to the future time, and then we equate it with the future revenues. So if you solve this equation, you can find out this I prime percent, and that is the ERR. Okay, so this is the external method, and then I want you to just understand the logic behind it. The logic is you just imagine that all the cash flows from a project, you could have imagined the costs at an earlier time on the external project. You also can invest the income of this project in the future time into that external project. And that's the case when you want to use the external rate of return method. Okay, the last concept is called payback period. Okay, so the payback period is talking about the number of n. So it tells you the number of years required for cash inflows to just equal cash outflows. Okay, so you have the initial payment for equipment, and every year it recovers some of your cost. But you want to know when do I have all the initial costs recovered, and then the time later than that, that's your pure profit, time gaining time. Again, that's the time. So to the years after that, payback period is gonna be the time you just purely get your profit. Okay, so that's the payback period method, and the payback period is often thought of as a measure of risk for a project, because if it takes longer time, then the risk is super high, because you never know, like after 10 years what's going on in the market. Although you can get your cost recovered after 10 years, but well, maybe at that time something bad will happen. So the longer payback period is, the higher risk you're gonna take. So tell me, it's just a very on common sense. Do you want the payback period to be long or short for an investment? Okay, just make your common sense. Of course, we want it to be short. We want to invest something, and then we even want to get all the cost back tomorrow, as fast as you can. Okay, so the payback period method, you always want to have a shorter payback period if you compare different projects. Okay, so that's it. That's all for chapter 5. And in the next class, we're going to open chapter 6, which is to use the same PW method, FW method, and AW method